Hello guys, welcome to another session. In this session, we are going to talk about primitive types versus reference type. So let's start our discussion. So far in our course, we have seen various types of data types like number, string, boolean, null, undefined, object. Symbol is yet to discuss. So one thing I wanted to let you know about the data types, all these data types which we have used so far, it is being categorized into two types, that is called primitive types and the reference type. And the data types which belongs to primitive types is numbers, string, booleans, null, undefined, and the symbol. And the other type of data type is a reference type. In this category, the data type which belongs to this is an object, arrays, function, dates, and all other objects which we will work with all belongs to the reference type category. So here the question comes over here is that what actually the primitive type and the reference types is. So the concept of primitive data types and the reference data type is related to the memory. That means how we are keeping the information within the memory. So what happens whenever we are creating a new number, new string and any boolean values, so it will be stored in something called stack. A stack is just a stack that has different values in a memory and it can be accessed very quickly. But a stack has very limited space within the memory. But when we create an object literal array functions, then it will be stored in a place called heap. Heap has more space available that is bigger, that will hold the object types. But the problem with the heap compared to the stack, heap is little slow. So here we understand that the first difference between primitive type and the reference type is that primitive type is stored in stack and reference type is stored in heap. Keeping the data in stack is faster than heap. But why a stack is fast and why heap is slow? The reason behind is the data exists within stack is directly available, but when we want to access the heap data, then it will be first loaded into the stack as a pointer and then it will be retrieved. So it will look something like this. So the data from the heap is referenced through the pointer within the stack. So whenever if you are accessing the reference variables, first it is being accessed to pointer and this pointer is being later referenced to the objects and their values, and then the values of the object is accessible. And because of this mechanism, stack is fast and heap is slow. So now let's jump into the Visual Studio Code, and I wanted to demonstrate you one of the major difference whenever the data exists within a stack and you are making a copy of that variable, what will happen, and whenever we are having a data into a heap that is a reference type and you are making a copy of the reference type, and if you are updating, then how reference type and the primitive type behaves. So let's jump into the Visual Studio Code to understand the copy behavior of primitive data type as well as the reference data type. So we are into the Visual Studio Code. So now let's look into the example. So what we will do, we will first create a variable called num1 and we will assign some value like 40, and then we will create another variable that is called num2 and I'm going to assign the same value which is being stored in num1. And then we will print it console.log, and within that we will use the template string and we will tell num1 equal to $num1 comma num2 equal to $num2. Save it. Let's look into the output. So you will find that it has printed the num1 40 and num2 40. Now let's proceed further and update one of the value. So now what we will do, we will update the value of num1 equal to 60. Save it. Now let's look into the output, what output we will get. So here you will find that it has updated the value 60, but it hasn't updated the num2. Why is it so? That is because whenever we are using primitive type, it will make the copy of primitive data type. So that means it will not affect to num2 because it is entirely available within different location of the memory. But this is not the case with the reference data type. So let's look into that. So now we will look into the reference type. So to see the example, we will create an object and we will make a copy of that object. So let's do it. Const emp equal to, we will keep two properties, name, Vanda, and age for the sake of simplicity. And we will tell that 45. And we will make a copy of this emp object, emp equal to emp1 equal to emp. Now we will console.log. We will use the template string and we will tell that emp, and we will emp age, and we will tell that $emp curly braces first, and we will tell that emp dot age, and same for the emp1. Save it, we will give a comma, paste it, and this time we will tell that emp1 over here and save it. Let's jump into the browser to see the output, and you will find that it has printed 45 for both the object. Now let's look into the difference. So let's jump into the Visual Studio Code. So this time I update the age of emp. So let's do it. So how we can do that? We will tell that emp.age equal to, and we will tell that it is going to be 50. Save it. Let's jump into the browser to see the output, and see here it has updated the age of emp and emp1, both of them is 50. But when we do with this with primitive type, it didn't happen. It has only updated the number 1, and in this case it has updated both the variable. So why is it so? Because we have created two variables in reference type, but it is referring to the same location. It has made only the replica of the reference. So let's look into a diagram to understand this concept. So when we use the primitive type, the num1 will be assigned to num2, so it make a replica. It is a separate copy. So now whenever I am changing any value within any of the variable, so it is changing to that particular variable. So it is not affecting the other variable. But this is not the case with the reference type. For reference type, what is happening? It is making the copy of the reference, but it is pointing to the same location. So that's the reason whenever if you are updating any value, for example, for the age case, we have updated from 45 to 50, and both are referring to the same information. So that's the reason the changes over here for emp age and emp1 age giving the same information. So I hope you have understand the difference between the primitive type and the reference type. So on this note, I am stopping over here. See you in the next session. Till then, bye bye, take care.